Homework, exercise 2, question 1. What is the gradient of a line perpendicular to the line with equation 4x minus 8y plus 3 equals 0? And the options are as follows: A minus 4, B minus 2, C 4, or D 8. Well, first of all, to find the gradient of this line, we'll rearrange it in the form of y equals mx plus c. So 8y is equal to 4x plus 3, but we need to divide through by 8 to get the form y equals mx plus c. So that's y equals 4 over 8x plus 3 over 8. The gradient of this line is 4 over 8, which can be simplified to 1/2. Now, we're looking for the gradient of a perpendicular line, so it's m1 times m2 equals -1. We flip the fraction and invert the sign, and the gradient of the perpendicular line is -2, and option B. Question 2. A function is defined on the set of real numbers by f of x equals x squared minus 1. Find an expression for f of x. And the options available are given: a, b, c, d, x squared minus 2, 2x squared minus 2, x to the power 4 plus 1, and x to the power 4 minus 2x squared. So f of x, well, f of x is equal to x squared minus 1. We can rewrite that as f of x squared minus 1. So wherever we see x, we're going to replace it with x squared minus 1. X squared now becomes x squared minus 1 all squared, and we're still taking away 1. We repeat the bracket here, so it's x squared minus 1 multiplied by x squared minus 1, and we're still taking away 1. Expanding out here, we'll get x to the power 4 minus 2x squared plus 1, and we're still taking away 1. Collecting like terms, 1 minus 1 cancels out, and we've got x to the power 4 minus 2x squared, and the correct answer is option D. Question 3. The midpoint of the line joining A5 and 5B is 2, 4. What are the values of A and B? And the options are given. A is -1 and B -1. B, A is -1 and B is 3. C, A minus 3, B 3. And finally D, A is 1 and B is -3. We'll remember that the midpoint is an average of the x and y coordinates. So the midpoint here is a plus 5 over 2, 5 plus b over 2, and we know that that is equal to 2, 4. So the average of the x coordinates is a plus 5 over 2, but that's equal to 2, so we can say that a plus 5 over 2 equals 2. Multiplying through by 2, that will give us a plus 5 equals 4, and solving that equation, a is -1. Similarly, 5 plus b over 2 is equal to 4. Multiplying through by 2, 5 plus b is equal to 8, and solving the equation, b is 3, a is -1, b is 3, correct answer is option B. Question 4. Here are two statements about the line joining the points P, 0, 5 and Q, -3, 5. Statement 1. PQ is parallel to the y-axis, and statement 2. The length of PQ is root 109 units, and the options available are A. Neither statement is true. B. Only statement 1 is true. C. Only statement 2 is true, or D. Both statements are true. Well, if we plot the points, P is 0, 5 and Q is -3, 5. We can see that the length of this line is definitely 3 units because we've moved from -3 to 0, and we've still got the same y coordinate, so it's a horizontal line which has a length of 3 units. Therefore, statement 2 is untrue. the length of the line is 3 units, not root 109. If the line is parallel to the y-axis, it's a vertical line with an undefined gradient. We can see already that it's a horizontal line, but let's just confirm that with calculating the gradient, which should turn out to be 0. So, for the gradient of the line, it's 5 minus 5 over 0 subtract minus 3, which is 0 over 3, and the gradient of the line, as expected, is 0. So in fact it's a horizontal line which is parallel to the x-axis. Therefore, statement 1 is also untrue. Option A, neither statement is true. Question 5. A function g is given by g of x equals 1 over x squared minus 4. What is a suitable domain of g? A, all real numbers. B, all real numbers except from 0. C, all real numbers except from minus 2 and 2. And D, all real numbers except from minus 4 and 1. Now we can see that in this function we would get an undefined result if the denominator was equal to 0. Therefore, the denominator for this function cannot equal 0. X squared minus 4 cannot equal 0, therefore x squared cannot equal 4, and taking the square root, x cannot equal 2 or minus 2, and option C is the correct answer, all real numbers except from 2 and minus 2. Question 6. A and B are the points minus 3, minus 1 and 5, 5. Find the equation of the perpendicular bisector of AB. Now remember that first and foremost the perpendicular bisector is a straight line, and this blue dotted line represents the perpendicular bisector. It's a straight line that cuts another in the middle and cuts it also at right angles. Now to find the equation of any straight line, we need the gradient and we need a point. So we can first of all find the point, which will be the midpoint of AB. So that's an average of the x and y coordinates. Minus 3 plus 5 over 2 for the x coordinates, and minus 1 plus 5 over 2 for the y coordinates. Minus 3 plus 5 is 2, 2 over 2 is 1, minus 1 plus 5 is 4, 4 over 2 is 2. The midpoint is given by 1, 2. We've got a point, we now need to find the gradient. We can find the gradient of the perpendicular bisector by first of all finding the gradient of AB. So the gradient AB is y2 minus y1, 5 subtract minus 1, which is 5 plus 1, over 5 subtract minus 3, which is 5 plus 3. That's 6 over 8, which simplifies to 3 over 4. Now, the perpendicular bisector, we're thinking about perpendicular lines, m1, m2 equals minus 1, and therefore the gradient of the perpendicular bisector, flip 3/4 over and invert the sign, is minus 4 over 3. We've now got the two things we need. We've got the gradient and we've got a point, and we'll sub into y minus b equals m bracket x minus a. So it's y minus 2 equals minus 4 over 3 bracket x minus 1. Multiplying through by 3 to get rid of the fraction, that'll be 3y minus 6 equals minus 4 bracket x minus 1. So we've got 3y minus 6 equals minus 4 bracket x minus 1, and expand it out, 3y minus 6 equals minus 4x plus 4. Rearranging the form ax plus by plus c equals 0 gives us 4x plus 3y minus 10 equals 0, and that's the equation of the perpendicular bisector for question 6.